So in question 1, we need to sketch this modulus graph. Key thing here is I've got a modulus graph here, modulus of 2x plus 3, and then a minus 4 on the end. So focus first on the graph y equals 2x plus 3, and then we'll do the modulus of that. So y equals 2x plus 3, I know looks like this. My coordinate here where it crosses is x is 0, y is 3. And then I would also look at the coordinate here where it crosses. Well, it crosses there where y equals 0, 0 equals 2x plus 3, minus 3 over 2 equals x. That's minus 3 over 2, 0 for that coordinate there. I want the modulus of this graph. So I would draw in the positive section that's already above the x-axis, then reflect up the part that's below. So at that point, this is y is the modulus of 2x plus 3. We've been asked to draw that graph minus 4. The minus 4 brings the whole thing down by 4 units. So now I can translate my coordinates here from 0, 3. This point here must be 0, minus 1. This point here, the vertex, the x coordinate hasn't changed, so it's minus 3 over 2, and the y coordinate there is minus 4. Okay. Now it's 5 marks this question, and it does say label its vertex, that's that point, and any points of intersection with the coordinate axes. Well, we've done the y-intersect. We now need to do these points here where it intersects the axis there. So our first point here where it crosses the positive part, that was my original graph of y equals 2x plus 3. So it crosses when y is 0, so 0 equals 2x plus 3 minus 4. And then this second part, in the reflected part of the modulus graph, will cross when this 2x plus 3 had the minus in front of it there. So I've now got the two equations to solve. I get x is 1/2 from the first equation, positive part. So the coordinates of that point are 1/2 and 0. And in the second part, I get x is minus 7 over 2. The coordinates of this one, minus 7 over 2, 0. Really important when we're drawing our graphs. It's this green one now. That is our final answer. When we draw in our graphs, that we are labelling all of those points of intersection with their coordinates. So in part B, we've already sketched our graph of fx, and that's the same here as what we were asked there. We want the coordinates of the points of intersection of that graph we've just sketched, and this one, y equals minus 1/4 x plus 2. So a gradient of minus 1/4, and it crosses at 2. So that would be the point 2, sorry, 0, 2. I can see there are 2 points of intersection here, and I need to work out each of them. My positive solution here comes from where minus 1/4 x plus 2 crosses 2x plus 3 minus 4. That's my first equation. For my second intersection point, this came from the reflected part of 2x plus 3. So that was minus 2x plus 3 in brackets. Then it was shifted down by 4, and it's where that part of the line intersects minus 1/4 x plus 2. So we've just got these two linear equations to solve to find x. Our first solution gives us x equals 4/3. Our second equation gives us x equals minus 36 over 7. Strongly recommend you do not go to decimals at this point. You do not. You leave it as fractions, as exact values. Now the question has asked us to find the coordinates of the points of intersection. We have just found the x values here, so we need the corresponding y values for each of these. use whichever one of these is going to be the easiest to evaluate that x-coordinate in. I would probably go for the one without the modulus in it. And our second equation leads us to y equals 23/7, or 3 2/7. So just to be clear then on our final answer, I would write them as coordinate pairs. By writing them in this way, there is no doubt that the 5/3 is the y coordinate for when x is 4/3, and that this 23/7 is the corresponding y value for when x is minus 36/7. I also personally do a quick double check, a sense check against the diagram that they look roughly right in the right places. This looks like it's going to intersect after x is 1/2 and I've got x is 4/3. The x-coordinate of this point, I'd expect it to be smaller, more negative than minus 3.5, which it is. Okay.